we're doing this week is demonstrating the capability for the United States Air Force to extend a leap ahead in force protection capabilities and technologies and integrate those technologies into a user-friendly system. We call it Smart Defender because we're using new smart technologies to take a leap forward in the capabilities that we're bringing to the fight.
And we're showing systems of systems to increase the situational awareness of the security forces.
The core of this effort was the integration of legacy, new, and emerging technologies. To accomplish this integration, the Northrop Grumman Mission Systems team leveraged the combat-proven capabilities of the Tactical Automated Security System, TAS.
We've pretty much redesigned the TAS system from the ground up. We're looking at all of the core capabilities of the existing system, preserving those, but then augmenting them.
To further enhance command and control, the TAS Annunciator was coupled with a Boeing 3D visualization tool called Visual Security Operations Console, or VSOC.
All of this data will be pushed to the Base Defense Operations Center or Central Security Control and displayed in a 3D image that we call VSOC.
Broadware's video management system controls the video cameras and feeds.
All the cameras that are around, placed in all the different scenarios, are managed via Broadware software technology. It allows you to control the cameras, pan, tilt, and zoom the cameras. It stores the video from those feeds, and it also allows you to distribute the live and archived views from all those cameras.
All of these systems are overlaid by a software-based Northrop Grumman Mission Systems-developed intelligent interface called Command and Control Integrated Collaborative Environment, C2ICE.
BDOC is where all of these systems come together to tie in all of the operations within the base.
The combination of these capabilities produced true situational awareness for the Ground Defense Force Commander.
We are using also a 5-zone layered approach, what we call the force protection zones, and that layers in-depth defense for each of our installations. We're applying multiple phenomenologies so we can not only have defense in depth, but also have multiple cues to the security forces to allow them to react faster and put weapons on target.
In order to best show the capabilities of the Smart Defender system, the demonstration was conducted in 4 separate scenarios.
The first scenario is what we call outside the wire. In this particular scenario, we're using Prince Sultan Air Base, Saudi Arabia, as the example. The threat on the ground is from a shoulder-launched surface-to-air missile. The area we're most concerned about, obviously, is that area that we don't control outside the perimeter fence.
What we're pulling in here is a new class of sensors, long-range sensors. This particular device, SEI M-STAR sensor, it has a 42-kilometer range.
It will then, through a queue to slew capability, relay data to the wide area surveillance thermal imager.
We automatically point this imager to the target.
We have also integrated a remotely operated weapon system called CROWS that can effectively bring fire to bear on the target once it's acquired.
As soon as the ground tracking radar acquires an enemy on the perimeter, it'll send a signal to the CROWS in the direction of the target.
A light sub-tactical unmanned aerial vehicle called Desert Hawk will be cued by the M-STAR radar to fly to the position of the intrusion and give us a God's eye view of what's happening on the ground.
This is integrated fully. As soon as a radar picks up any targets, that'll send a message to us saying, do you wish to surveil the area? As soon as we select yes, the vehicle will peel off and head out to orbit the area.
We have added a new capability called Terrain Commander.
Terrain Commander is used to supplement the deficiencies that you'd expect from a line-of-sight radar system.
Terrain Commander is a multi-phenomenology sensor. It has seismic, acoustic, and magnetic sensor suite on board. It also will relay an image of what it has tracked through satellite link back to the Base Defense Operations Center.
What we're looking at we got was from the Humvee, which just came down the road. You can see the Humvee in the background, and then the troops in that frame right there.
The last piece of the equation is to give the fire team leader who is responding to this event a handheld device that has a map that shows the intrusion taking place, a video feed to give him an indication of what he's actually got in front of him, and then finally an IFF capability which will identify his location in relationship to the threat back at the BDOC. All of these capabilities will then be integrated into a command and control network that will be displayed in the BDOC, very much like the display you see here.
The MSTAR ground surveillance radar detects a target within its assessment zone. The operator marks the target, automatically sending an alarm to the BDOC, as well as automatically cueing the Wide Area Surveillance Thermal Imager, remotely operated weapon system, and the unmanned aerial vehicle to the position of the intrusion. The commander in the BDOC can see personnel discharged from the unidentified vehicle and dispatches a response team to intercept the intruders. The responders are equipped with handheld PDA devices, providing real-time situational awareness. Terrain Commander, deployed along likely avenues of approach outside of the defensive perimeter, detects an approaching vehicle and sends a second alarm. Video images of the second intrusion are displayed in the BDOC, where the commander can respond appropriately.
In scenario number 2, we're going to demonstrate rapid positive base access control. What we mean by that is the ability to very rapidly push vehicles and personnel through the base entry points. This particular scenario also allows us to ratchet up the security of the installation as we ratchet up the force protection conditions.
SmartGate is an automated solution to gate security. It brings together the latest in commercial off-the-shelf technology. It's an open architecture, highly expandable, high-tech solution to both manned and unmanned gate security. What you see behind me over here is a license plate reader. Just ahead of that, it's a smart card system. Smart card has a code on it which identifies uniquely that vehicle and that operator. This is a barcode reader and a hand scanner.
This vehicle is attempting to access the base through the SmartGate. When the driver fails the hand scanner, an alarm is generated and access is denied. This system can be immediately configured to meet force protection condition requirements by turning on or off selected identification technologies.
A second part of scenario number 2 is a contractor gate operation. What we're trying to do is detect large vehicles laden with explosives. We're using a system developed by SAIC called VACIS, Vehicle and Cargo Inspection System. VACIS gives us a gamma ray image of what's inside that vehicle.
What we're looking at on the screen are density variations. For example, here, right in the center of this container, we have a very dense object that doesn't match the rest of the cargo.
Scenario number 3 is a flight line alert area scenario. The Air Force has asked us to demonstrate the ability to detect, assess, and put extra layers of detection around critical resources such as a flight line alert area, a fighter alert area, presidential support aircraft, and other significant high-value Air Force assets. This is the next generation of video motion detection systems.
Instead of requiring an operator sitting there looking at each monitor, we've got software that's doing that 24 hours a day.
Coupled with a layered approach using TMPS. That sensor data will be fed through the annunciator to the BDOC, the Base Defense Operations Center, where the controller will get a signal that something's occurred.
An intruder attempts to access the protected flight line. The video motion detection software developed by iNetCam alerts to the initial intrusion and sends an alarm. A second line of detection, consisting of the Tactical Microwave Portable Sensors, TMPS, by Perimeter Products, activates and sends an additional alarm on the intrusion. A response team is then dispatched to apprehend the intruder.
In this case, we are demonstrating a number of new technologies in a layered approach to provide defense in depth of our weapons storage areas. The first piece that we will use is a man-trap automated entry system. This system combines three different phenomenologies: a card swipe, hand geometry reader, and a facial recognition capability.
The first biometric is hand geometry. The users have to together pass hand geometry, then they step inside the portal and they have to pass face recognition. He fails, and you can see on the screens that they're not accepted and not allowed in. Neither door opens.
The intrusion piece of this scenario will start at about 400 meters from the perimeter fence. This will be done with sensor phenomenologies, the first being an ARS sensor, ARSS, developed by Telephonics.
It'll detect the intruders at a large standoff distance.
We're using the ARSS in combination with a PSRS, which is also a short-range ground surveillance radar.
That has a 300-meter range, so it still pushes the defense area well outside the perimeter.
The PSRS will relay its information through the Vindicator Annunciator to the Wide Area Surveillance Thermal Imager, which has a new capability in Octec software, which allows us to track and identify threats as they approach.
Closer in yet, there's the Cupid sensor. That has a tunable range from 30 to 90 meters.
The final piece that we have added to this scenario is MDARS.
The Mobile Detection Assessment and Response System, with its intrusion detection systems and its camera systems, is being used in this exercise as a response to an intrusion that's been detected by other sensors.
Far outside the perimeter of the weapons storage area, the advanced radar surveillance system produced by Telephonics detects and tracks an intruder. The ARSS automatically cues the Wide Area Surveillance Thermal Imager, and the intruder is tracked using the adept video tracking software developed by Octec. As the intruder closes in on the facility, the layered sensors are activated. Perimeter Surveillance Radar System, PSRS, by SensorTech, and the Quick Reaction Perimeter Intrusion Detection Sensor, CUPIDS, by Curtiss-Wright. Finally, the Mobile Detection and Response System, MDARS, is dispatched to intercept and assess the intruder. This scenario also demonstrates the integration of the Vindicator Smart Annunciator into the command and control system.
The most important part of all of this is the integration of these technologies into a command and control network that will give our forces much better visibility into what's happening out at the perimeter, inside the storage areas, on the flight line. And that's what we do best. We have integrated this system with a true command and control system that gives the defenders immediate information, immediate data, immediate video feed from a variety of sources, and gives them an accurate picture of what's happening on the ground. At the end of the day, what we have done is put together the best of breed capabilities in the security world. We've added integrated C2 situational awareness, secure wireless comm to give our end users full dimensional protection.
This Smart Defender demonstration in December of 2002 by Northrop Grumman Mission Systems pulled together the best and brightest of legacy, new, and emerging force protection technologies. This team of 23 companies planned, developed, integrated, and demonstrated in less than 90 days a true leap ahead in capabilities to support the warfighter, allowing security forces to see first, understand first, and act first.